So, there's an infinite number of universes that are possible right in your room. Reality as we knew it was all wrong. It is the basis of all life on Earth, and we still don't know quite how it works. The most intricate quantum device is you. What if I told you that the Mandela effect might not just be a trick of the mind? Quantum computers have just analyzed this bizarre phenomenon, and the results are raising serious questions about how reality itself works. For years, millions of people around the world have experienced false memories, recollections of events, names, and historical facts that don't match the official records. Was Nelson Mandela's death in the 1980s real or just a widespread misunderstanding? Was it always Looney Tunes, not Looney Tunes? These discrepancies have puzzled psychologists, who often attribute them to the brain's tendency to reconstruct memories inaccurately. But what if there's something more to it? Now, scientists have taken a new approach to studying the Mandela effect using quantum computers, the most advanced processors ever created, to analyze patterns in these shared memory distortions. Could this technology provide the first real clues about what's really happening? And what they just uncovered will shock you. What makes it so strange? The Mandela effect is one of the most baffling psychological phenomena ever recorded. Millions of people across the world claim to remember events, logos, and phrases differently than they appear today. These aren't just isolated cases. Entire groups of people share identical false memories, which has led some to question whether something bigger is happening beneath the surface. Some of the most famous examples include Nelson Mandela's death. Thousands of people distinctly remember news reports of Nelson Mandela dying in the 1980s while in prison, yet historical records confirm that he actually passed away in 2013. The Berenstain Bears vs. The Berenstain Bears. Many people insist the famous children's book series was always spelled Berenstain, yet every official record shows Berenstain with an A. Looney Tunes vs. Looney Tunes. If you thought the iconic cartoon was called Looney Tunes, you're not alone. But the official name has always been Looney Tunes, which many find odd given that Tunes doesn't match the animation theme. The Monopoly Man's monocle. Many people clearly recall the Monopoly mascot wearing a monocle. However, official designs have never included one. Darth Vader's famous line. The most quoted line in Star Wars history is, "Luke, I am your father." Except that's not what he actually says. The real line is, "No, I am your father." But why do so many people share the same false memories? One explanation is that it's simply a cognitive glitch, our brains filling in missing information based on expectations and patterns. But others suggest something far more mysterious, that the Mandela effect could be evidence of parallel realities briefly overlapping, causing some people to retain memories from a different version of history. The role of quantum computing. And this is where quantum computing comes in. What happens when a quantum computer, capable of analyzing reality itself, studies the Mandela effect? The results are even crazier than we expected. If you love breaking discoveries like this, make sure to subscribe. We bring you the latest updates you won't hear anywhere else. The turning point. Quantum computing has been introduced as a potential tool for analyzing the Mandela effect. Unlike traditional computers, which operate using binary bits, zeros and ones, quantum computers process information using qubits. These qubits can exist in multiple states at once, a property known as superposition, and can influence each other through entanglement. This allows quantum systems to analyze vast amounts of data simultaneously, detecting patterns that classical computers might not easily recognize. Researchers applied this technology to examine recorded instances of the Mandela effect, focusing on whether large-scale memory distortions followed any specific trends. By feeding quantum models datasets containing millions of reports of shared false memories, they sought to determine whether correlations existed across different time periods or cultural shifts. Michio Kaku, a theoretical physicist, has spoken about quantum mechanics in relation to reality, suggesting that quantum principles could have implications beyond subatomic particles. Some researchers have explored the idea that quantum effects might influence perception, though this remains an open question. The strange pattern quantum computers discovered. The analysis of the Mandela effect using quantum computing led researchers to identify unexpected trends. The data suggested that reports of shared false memories were not randomly distributed but appeared to cluster around specific time periods. Notably, the late 1990s and early 2010s stood out as key moments when large numbers of people reported experiencing Mandela effect cases. Further examination revealed a strong correlation between these time periods and major technological and cultural shifts, including the rapid growth of the internet and digital media, leading to new ways of accessing and spreading information. The transition from analog to digital formats, including changes in TV broadcasting, the shift from VHS to streaming, and the replacement of printed materials with digital archives. Large-scale global events that may have influenced collective memory formation and how information was stored and retrieved over time. These findings raise new questions. Were these memory distortions simply a result of mass misinformation amplified by technological changes, or was there something else at play? If the Mandela effect is purely a psychological phenomenon, why do so many unrelated people recall the same incorrect details? Some researchers have proposed alternative explanations, suggesting that certain principles in quantum physics may provide a different perspective on why these anomalies occur. Is reality shifting? As researchers analyzed the patterns found in Mandela effect cases, several possible explanations emerged. The intersection of quantum physics and memory distortions led to three primary hypotheses that attempt to make sense of these findings. Mass memory distortion. The AI model suggests that human memory may be highly susceptible to changes in digital information storage and retrieval. As society transitioned from analog to digital formats, subtle alterations in media branding and historical records may have contributed to large-scale memory inconsistencies. The quantum wave function collapse hypothesis. Some physicists propose that reality exists in multiple potential states until it is observed. In this view, individuals may experience different versions of reality before consciousness collapses one into a singular, stable version. Could it be possible that groups of people retain fragmented memories from alternate possibilities before they were locked into a true timeline? Parallel reality shift. Quantum mechanics demonstrates that particles can exist in multiple states at once through superposition. Some theories speculate that reality itself might function similarly, with different versions coexisting until an interaction forces one to become dominant. If this concept extends beyond the quantum scale, could people occasionally retain memories from slightly different timelines? These ideas challenge conventional assumptions about how memory and perception work. If certain quantum properties play a role in shaping reality at a macroscopic level, it could suggest that memory distortions are not just errors, but glimpses of alternate outcomes that once existed. Can scientists prove quantum computers detected reality shifts? Scientists are now exploring ways to test whether quantum computing has uncovered something deeper about the Mandela effect. While the idea of reality shifts remains theoretical, several new experimental approaches have been proposed to determine whether memory inconsistencies follow predictable patterns and whether they might be linked to quantum mechanics. One approach involves comparing human memory recall to quantum probability distributions. Some researchers believe that if memory distortions were purely random, they should follow a scattered pattern. However, if they align with known quantum interference effects, it could suggest a deeper connection between consciousness, perception, and the structure of reality. With more quantum AI experiments planned, real-time global memory studies may offer a clearer picture of how perception is formed and whether our understanding of reality is as stable as we believe. But if this isn't just a coincidence, what does it mean for the nature of time and reality itself? Quantum computers have just analyzed the Mandela effect, and the results raise new questions about memory, perception, and reality itself. Instead of being purely random, memory distortions appear to follow distinct patterns, often linked to major technological and cultural shifts. So what happens next? Could future quantum systems reveal even deeper insights about how we experience time, space, and consciousness? What do you think? Is the Mandela effect just a psychological glitch, or could it be something much bigger?